Now it's time to deep dive into Kubernetes Object Service. Service, if you want to expose your pod, the application running in the pod as a network service, like you want to host Nginx or a Tomcat or any front end or even for the back end, you need to use service with your pod. Then a service is similar to load balancers, like what a load balancer does. ELB, Elastic Load Balancer in AWS. Same service will be doing for the pod. So for the starters, it's really not so difficult to understand. Just like a load balancer, and you want to expose your pod communicating with each other, you need a service in front of your pod. A service is abstract way of abstract way to expose an application running on a set of pods as a network service. With Kubernetes, you don't need to modify your application to use an unfamiliar service discovery mechanism. Kubernetes gives pods their own IP addresses and a single DNS name for a set of pods and can load balance across them. So then the question arises, so why was really a service created? So why do we need a service altogether? If we don't use service, is it not possible to run our pods, run our application using Kubernetes? So actually the issue is Kubernetes pods are created and destroyed to match the desired state of your cluster. Yes, correct or not? Yes. So pods are non-permanent resources. This is the pain point. If you use a deployment to run your app, it can create and destroy pods dynamically. Each pod gets its own IP address. However, in a deployment, the sets of pods running in one moment in time could be different from the sets of pods running that application a moment later. So this leads to a problem if some set of pods, let's take an example, backend pods provides functionality to other pods. Let's take them as a front end pods inside your cluster. How do the front ends find out and keep track of which IP address to connect to, so that the front end can use the back end part of the workload? So if there is no proper connection, if continuously the front end, the back end is changing the pod, changing its address inside the cluster, then how can the front end can catch up, can bring them, can connect with the back end to show the required features and functionality on web application UI? Of course, it's difficult, it's impossible. That's where the service comes into the picture. The service comes into the picture and it makes a proper connection between back end and front end. A solid connection it will make. That's the main reason to have a service. So in Kubernetes, we have three types of services. The first one is node port. A node port which is similar to port mapping. Node port is nothing but it's not just similar, it's almost equivalent to port mapping. So we have seen in a Docker a host port you pick up and you map it with the container port. Yes or no? We have done it. We have done it 15-20 times during each and every exercise of Docker. Kindly go back to the Docker module and watch it. So node port exposes the service on each node's IP at a static port. Basically, we call it as a node port. To make the node port available, Kubernetes set up a cluster IP address the same as if you had requested a service of type cluster IP. So it's exactly the same way, and mostly it's exactly the same way as the port mapping of the Docker container. So, and mostly it's for a non-prod purpose, not for production. So, this node port mapping node port service will not be used for the production purpose. So, not for exposing the front end to the production. And only this is to expose your pod to the outside network. That's it. This is limited, and node port is only limited, so it's impossible for you to expose. For example, you have two pods, one is front end pod, other one is back end pod. So it is difficult for you to expose the back end pod to the front end pod it's difficult. With node port the only thing that's possible is you can uh, expose the front end pod to the front end pod to the external network or outside network. That's why you can use a node port only for exposing your pods to the external network. Then you may ask, how can I expose internally one pod to other pod? So for that we have few more services. The second one that we have is a cluster IP. If you don't want to expose it to outside network but internal, like Tomcat connecting to MySQL. So for MySQL you need a static endpoint. So you can create a service of type cluster IP. So cluster IP exposes the service on a cluster internal IP. So choosing this value makes the service only reachable from within the cluster. Within the cluster, the problem that we have discussed during the node port service has been solved using the cluster IP. So this is the default that is used if you do not explicitly specify a type for a service. So you can expose the service to the public with an ingress or the gateway API. That's if you want to expose this to the external outside network, then you can use either ingress or the gateway API object. But however, we are not worried about that. So cluster IP for internal communication. So here there will be no port mapped to your node internal communication. Then the third service that we have is a load balancer. It will do both. So third one you have is a load balancer. It exposes the service externally using a cloud provider's load balancer. It's gonna connect with cloud provider's load balancer. So this is again to expose to the outside network for production use cases. It's basically widely used. Load balancers are widely used for the production use cases. So we are running a Tomcat pod and I want users from the internet to access that. I want consumers and users from the internet to access that. For that, I will create the service of type load balancer, and on AWS, it's going to create actually an elastic load balancer and map my pod to it. So then we will look into the services object high level architecture. So every pod or a cluster of pod that are running, you need a service in front of that. If it is a network, if it is providing a network service, okay, like a front end, we will have a service for backend. Example, RabbitMQ, Elastic Cache. You will have again a service in front of it, and MySQL, you will have a service in front of it. Everywhere you see that service here, service here, service here, and service even for the MySQL database. So that's how the communication happens between pods and between user to the pods. So first we will understand the service of type node port. This is specifically about node port. So node port architecture. So let me change this. It's to node port. And so let's say you have two pods running inside a single cluster. This is our the yellow color one. This is our node port. Sorry, this is our node. This is our node. That means one EC2 instance. Inside that, two pods are running. Pod 1 and pod 2 are running. So you have two pods running over here. So pod will have label and pod will have an IP address, and of course container running inside that will also have an IP address. So the Nginx container is running on both the pods, one container per pod, uh, and it's exposed on port 80. That's 80. So okay, so pod has an IP address and a port number to access it, and has a label too. So now service will be like a load balancer, as I said, in front of it. In front of it, so service will have a static IP address. Okay, so this is our service. The service will have a static IP address which will not change until unless you don't delete it. That's the benefit. So this is not dynamic, it's a static address. So the service will have a static address. So it will have a front end port, like a load balancer has a front end port. So you see that this is the back end port. You have a front end port, and this port will be mapped with the port of this Nginx pod. And similarly, the port of this service will be mapped with the port of the Nginx pod. And similarly, you have a port mapping. This is external port mapping, and this is node port of the node. Okay. Then we have, this is the internal front end port. This is internal front end port, and we have here the it's for internal communication. The internal front end port is for internal communication, and it has a back, and it has back end port. Back end port, that is back end port will be the port number of container, obviously. Okay, service like a load balancer has a front end port and back end port, but how does it know which port it has to route the request to? So there could be hundreds of ports running like this. Well, it's going to match the label selector. It's going to use a label selector. This is what you see, that label selector. Using label selector, it's going to find out the that pod. It's going to use a label selector to find out the port, and then port mapping also will be done. So port, this port will be mapped to this port, and then how would that find out that pod? Using the label selector. Now, so we give a label name, any pod that has the label app front end, any pod is going to forward the request to that pod 80. So now, two part, it run exactly. Now, okay, this is internal. When you say node port, you have to mention a node port number. Say, let's say 30,000. This is a 30,000, and so a node port, this is a host port. 30,000 will be mapped to your service. When you access the node by giving its IP address and the node port, the request will forward to the service. The service is going to forward the request to the pod. Pod will send it to the container, and the same way it comes back. If there are multiple ports over here, the similar thing. This is our the IP and node port IP. This is a node IP, and this is node port. when you call a node IP with the port, this will be connected, this will be communicated with it will be communicated with the internal port 80, and then that will be connected with the port of pod, and pod will connect with the port of Nginx using IP as well as ports. So that's what the node port is. So now let's look into the one example here. So let's defining a service first. For example, suppose you have a set of pods where each listens on TCP ports 9376 and containers a label. So this is how it looks. So basically a service definition file looks like this. You see that? In Kubernetes, a service is an abstraction which defines a logical set of pods and a policy by which to access them. So the set of pods targeted by a service is usually determined by a selector, that you can see that which pod you want to target is determined by the selector. So for example, consider a stateless this one image, and here the selector has targeted specifically this pod. Then obviously when you run this service, when you create this service with the port mapping will be done to the this pod. And another example, so it consists of API version kind in addition to that metadata, whereas in spec the most important is selector, and then in ports you have to mention this protocol as a TCP, and then port name either you can directly give 80 or you can mention the port of target port is the one which should be mapped properly. The target port either you can give it a port ID port directly, or you can give the port name also if it is mentioned in the pod. So here this is a service. On other side you can see the pod. So pod definitions in pod have names, and you can reference these names in the target pod attribute of a service. For example, we can bind the target port to the service to the pod port in the following. Let's see that example. Now you see that this is the pod. So pod kind Nginx labels. Label is important. Then spec, and in ports we have mentioned the port, container port and 80. So the name of the port we have given as HTTP web SVC. So now in spite of mentioning the target port as 9376, what I can do is I can directly give the name of the target port of the pod. So the pod has to be targeted. The pod selector has to be mentioned here. And you see that selector, that's a proxy. So these are the main important points to be taken care before you run a service. Run service to service is pretty simple. It's just compare, just take the analogy of any web application deployment. You will have a web app, your app, okay, an application. To run that application, we are using either HTTP or Apache 2 or Nginx or any other kind of service. Yes or no? Similarly, what that service makes? The service makes the communication possible with the external or outside network through internet using browser. Similarly, here the service is one object that we are going to create, but this object what it's going to do is our pod is equivalent to our application. Now this object, this service object will make sure the communication possible between external network as well as internal network. If it is a node port, it is only for the external network communication, whereas internal, where if it is a other cluster IP, it's for internal. If it is a load balancer, you can manage both. So that's how a service a service object basically makes our pod to externally access through internet or browser. So first let's do this example. Service object, the node port service, and here we are gonna do node port service. This example we are going to take. Okay, so for this, I think it's time to get into the action. It's pretty simple. So here we will have a pod. The pod could be in any node. It could be in working node 1 or working node 2, it doesn't matter. Whereas the service that we are going to create can be in any node. It could be the service can also be in master node. It will be across all the nodes. So master node, working node, and this. So when we create a master node and when we check the master node, we should able to find the endpoint where that endpoint is connected with this pod. So now it is, if the service is properly connected with the pod, then we can directly go to the browser. Using the IP of that service, we should able to access the using the IP of any node. It could be master node or working node, or master node or working node, because service exists across all the nodes. So that's the reason any of your from any of your node you should able to access the service, and then your pod, and then through your pod your application. I hope you got it. So let's do the exercise so that it will be much clearer. So now it's time to get into the example. So it's node port architecture example demonstration. So let me get into our COPS. Sudo option I, clear the screen. So let's do ls cd defs. So now I'm going to create svc mk dir svc defs. So cd svc defs. Inside that, I'm going to create one more directory, that is mkdir. So first service we are going to explore is node port svc, cd node port svc. So here we are gonna create our pod first, then after the pod we are going to create a service. So let me do vim. Okay, but first, before that, let me get the pods. So get kubectl get pod. I think our vpro app is up and running. So let me clear the screen and say vim. It's a wipro app dot wipro pod dot aml. So let me, basically we have that file ready. So this is what the one we have used. So let me copy this. We have used it uh, so far so many times, so that's why I'm using the same. So I don't need to explain again. So that's it. Then now it's time to create the service. Anyway, that pod itself is running, so we don't need to touch. Now service. So for service, vim wipro app, this is node port dot aml. Let's create that service. We'll create the service first, and here I'm gonna say Wipro app node port dot aml kind, I'd say service. Okay, API version v1 kind service. Yes, we got a sample file, so let me remove this. Yeah, rest all fine. So kind is service, metadata. So name, I'm gonna say name of this is hello world service. That's the first one. So we have named it like that. And spec. So what will we do is this is ports. We'll keep that. Selector is not required in this. Ports, and inside the port directly I'll mention 8090, and the target port well, okay, before that let me mention the node port. Its node port is 30,000, right? Yes, 30,000. Then we have the target port. So I think port name that we have given there is Wipro. Let me cross check. It's a Wipro. Yeah, it's Wipro app port. So Wipro app port. Wipro app port. And protocol. The selector we have removed. We should not remove the selector. Okay, we will attach the selector again, or we'll attach the selector at the bottom. No issue at all. Or else we'll attach the selector here itself. Yeah, selector app. It's a Wipro app. Then type I'm gonna give noteport. Everything is absolutely fine, no issue at all. Okay, so let's copy this and paste it here. That's it. Let me do WQ. So our service definition file is ready. So now let's compare both the files. So cat wipro pod.ml and let me check cat wipro app node.ml. Let's check. So name is fine, that's anyway specific to this. And selector, let's check that selector what I'm selecting, Wipro app. Is the name is same, app Wipro app, absolutely fine. See, name is Wipro app, even the label is also Wipro app, the labels tag that we have mentioned here. So one more thing that I just want to say, like if you want to know, here inside the file these are all dictionaries and this is a list, and again this port item is also list. Okay, um, now the selector is absolutely fine, no issue at all. Then type is node port type, because we are working with node port type service. Then port mapping 8090, inside, and node port, the port of the node is 30,000. Let me show the picture first. You see that? Not this one. Yeah, this one. See, this is the node port of this node, port of this machine. Then this one will be mapped with this. You will have that node port static service. That service will have a static IP, and then it will have a port, and this port will be mapped with the pod, and then the pod's port will be mapped with the container. So that's how from external world, using browser, using node IP and the node port, you are able to connect to the container. So let's get back to the service again. Yeah, so I think it's clear. So node port is clear, 30,000, which is used to connect from external world, and port is 8090, which is static. Basically, this neither port, this port and this IP is also static, and then target port. This is a Wipro port, Wipro app port, because we want to target this pod, okay, this container directly, that pod's container. So the pod's container's name is this Wipro, okay, protocol TCP. Rest all fine, absolutely fine. I hope. Let's see that what's gonna happen. So now let's create the service, but before that, let's check is do we have any services here? Cube CTL SVC? No. Okay. Um, let's cross check. So okay, existing some Kubernetes service is there, but that's absolutely fine. It is not a big deal. So let's create a service. kubectl create and F option, and the name of that service is, what's the name of the service that we have mentioned? Sorry, that definition file, Wipro app nodeport.ml. Let me execute that. Absolutely fine, no issue at all. Service hello world service is created. Now let's say kubectl get svc, and here is that hello world service and node port, and this is the cluster IP, and this is the X. Oh, okay. This is our, look into this endpoint. Okay, this is our internal. You see that 8090 internal, and this is 30,000 is external. I'll show you that again on the image itself. You see that 30,000 is the node of this port, or sorry, port of this node, or port of this EC2 instance in other way. Okay, and then 8090 is the service port. Basically, it's a static IP. The service will have a static IP and then port. So now 30,001 is mapped to the 8090, and this 8090 is targeted to the container port through the pod. That's what the magic is happening here. Okay, now let's get back to the work again. See, 8090 is our internal, and 30,001 is external, and then TCP is our protocol. Now let's describe the container. So let me say kubectl describe svc, and what's the name of this container? Hello world, and it's service. That's what the name we have given. So here is that endpoint, and it begins with the name hello world services, and the namespace is default. By default it takes the namespace, as we have discussed in namespace session, that if you don't specifically mention the name, then namespace then it's gonna take the default namespace. Selector is very important. So using this selector itself, it has selected the respective pod, and then type is node port type, and then IP version 4, and these are the IPs, and target port is Wipro app port, so that's 98080, I guess. Then we have 30,002 TCP. Then endpoints is this. This is our endpoint. Let me copy this and let me put it in sticky notes. So then we are going to use this later just for the comparison. So now what I'm going to do is, so the endpoint, what it says is the endpoint. This is the endpoint of the container. So it's going to connect it. So our hello world service, let me show this again. This hello world service will be connected with the endpoint, the container endpoint directly. So whatever the endpoint it is showing should be the container. So container IP. Let me check whether it is yes or no, whether it is same or not. So for that, I have to describe the kubectl, describe pod, and then name of the pod is Wipro app. Okay, describe, sorry, pod, it's Wipro. I think it's okay. Before that, let me do kubectl get pod. Yeah, it's a Wipro app, so no issue at all. So let me do kubectl describe, and it's describe pod Wipro app, and then grep IP. You see that this is the IP of our pod, IP of our pod. Inside that our container is running. So once you access the pod, and the pod will be connected with the container. So let me take this and copy it in the sticky note, and let's compare this. You see that both are same, both are same. That's what I'm saying. Hence it's proved, hence it is proved. So the service, the static IP of the service is mapped with the pod IP, and in turn the pod will be mapped with the container. So in turn, when I access the node IP with the node port through the service port, through the pod port, through the pod, it will connect with the engine container, and inside the container port we will have our application running. That's what the architecture. So now we have seen enough, so we got that. So endpoint automatically mapped with our pod, so that's the power of using service. Now let's see who said basically the mapping is also automatically, the endpoint is automatically created by the service. Okay, so now let's access the app from our browser. For that we need to add some SG rule, the security group rule, because we're not sure, we haven't. Let's get into the EC2 instance. Master, anyone, let me take uh, any node, or else I'll take master group, because the service can run from anywhere. So I'll take the master itself, and let me come scroll down and get into the security group. Security, oh, there are a lot of security groups. Let me scroll down. Security, yeah, we have one security group here. Sorry, that's a storage from ingress. and like that. Okay, let me click on this. How many security group rules are there? So for permissions, we come to the inbound rules. So a lot of inbound rules are there. Let me click on edit inbound rules. So a lot of stuff is there. So all traffic is also there. So let me add one more. This time I would say all traffic and my IP. That's it. And I'll save the rules. So the nodes.kubewebpro.mlac, it's been added. So now it's time to take the IP of the so now it's time to take the public IP of the node, or any node is possible. So it really doesn't matter which node is the pod, which node is the pod is running, because we are going to access the service which is across all machines, even in master node. So let's get into that. We'll take that EC2 instances, and it's copy this and put it here, and it is port number 30,000. That's it. Here it is. Our app is up and running. And technology about blog login sign up. You can click on login, and you can sign up. Yep, you can sign up. You can do the login. So whatever you want, you can do that. Let's get back to our work again. So now it's been proven, so that we are able to run a service. Through that service we are able to access the container which is running inside the pod. Okay, so let me show this one more time so that it will be much clearer. This is our node EC2 instance. Inside that one, we have created one pod. That pod consists of one container, which is the container consists of our application. Example, vProfile application that you see on your screen. Okay, all clear right till now? So now to access this application we need some service. Similar, even in manual deployment, traditional deployment also, we need to have some service. For example, example Apache 2, HTTPD, Nginx, whatever it may be. Here also we require a service. For that service, what we will do is we will write a definition file. Inside the definition file we mention which pod to be targeted, and and which port to be targeted, which pod, and then that pod's port, both will be mapped. Once it is mapped, then we will access the node with the port, and anyway node port will be mapped with the pod, and pod will be mapped with the nginx. So that's how the flow goes, and that's how we are able to access our application that you see on the screen here. Okay, so now let's get into our machine, and then let's delete this service first, because we are going to run a second type of service, that is load balancer service. For okay, mhm. So now let's delete that. It's kubectl delete SVC. First we'll get the service kubectl get SVC, then kubectl delete space name of the service is this, copy and paste it. Okay, so it's been deleted. The service hello world services is deleted. So now let's clear the screen and let's write load balancer. So before we write that, let's get into our theoretical concepts. Service node port. So now it's time to look into load balancer. So here you see that ELB endpoint will be there, and then you have an application load balancer. Now this application load balancer, in spite of port mapping, this will work on a different way. So it's you will have a service, and the service will have a IP, static IP, and then port, and then label selector basically will select the pods, and then app front end, so backend port. So similar rest all works similar way, and then all will be mapped. So with this service, all will be mapped with this service, not through the port. Again I'm saying it is not through the port. It's not through the port, it will be through the IP, and then that service itself. Here which service we will get it, we will take the load balancer service from the AWS, because now we are doing it in AWS. So here elastic load balancer, the ELB of the AWS service will comes into the picture, and this will connect with all the pods which are there inside that, based on the selector. Okay, the node port is depends upon node port mapping, whereas here this service is depends upon load balancer functionality. Okay, so now let's begin our action. So let's do mkdir lbsvc, that's a load balancer service, ls, yeah, lbsvc, and inside that we'll create the vim. Okay, or else we'll get back to that directory and there we'll find out. Copy, inside that we're going to create vim wipro load balancer dot ml. Okay, let's write this file. So let me create a new file, load, sorry, pro load balancer dot ml file. So kind, it's service, yeah, Kubernetes service. Click and remove this part. So kind is service, metadata, the name I'm gonna give for this service is, this is load balancer service. Then selector will name is done spec. Inside that selector I'm gonna say app, it's wipro app, that's what we have been using, wipro app. And after that we should have type. So we missed a type here. Type, it's load balancer. Yes, we got it. Done. Then selector is done, type is done. Now it's time to attach the ports. So port mapping. Now here it's 80 because we are using the load balancer. So load balancer is at port 80 is absolutely fine. Then target port. Target port, I think it's a Wipro app port. We have used it. Yeah, here it is, Wipro app port. Then the final one, protocol. It's TCP. Yes, got it. All got right. No problem at all. Let me copy this and paste it here. That's it. WQ, save and quit. Now let's begin. So let's create a load balancer service. First, for that, kubectl create option F and Wipro app, Wipro load balancer.aml. Let me execute it. Here is it. Service load balancer service is created. It's better to copy this and keep it. When we are deleting it, it would be easy, or else we are typing something and some other thing is happening. Okay, so now our service is ready. Now let me say kubectl get svc. Here it is. Load balancer service. It's still pending. So once your external IP, that's endpoint, is up and running, you can get into your EC2 instance. Yeah, it's here. Yeah, so you can get into your EC2 instance and you should see your load balancer running. Let me click on load balancer. So here you should see your load balancer up and running. Once your load balancer is running, you can copy the file, copy the link from description from the load balancer, and if you paste it, you should be able to see the application. So that's how a services object through load balancer works. Yeah, it's all done. Now it's time to delete the pod as well as services. So kubectl delete pod, that's Wipro app. That's it, it's been deleted. Now kubectl delete service. Hell, this is load balancer service. That's it, this has also been deleted. Now it's time to wrap up the service object and we will enter into another type of object in Kubernetes.